Okay, this is Fred, chapter 17, and it starts on page 109 in the book, so write that down so I'll know it. I'll tell you when you have to write something here. You don't have to write anything until I tell you to, okay? And just to get started, dairy, there's protein in dairy, which helps you build muscles, and there's calcium, which helps your bones grow, and Fred thought that was pretty cool. So Betty handed Fred a serving, which was 1 quart of ice cream. If you remember, they're still at the pizza place. Fred still, he's been giving a speech. We have all these people there. He had that fancy ice cream machine. So Betty handed Fred a serving of ice cream. And she wanted him to eat it because she thought that the protein in the milk would help him get strong as well, and the calcium would help his bones grow. Excuse me. Now, Fred took the bowl of ice cream that Betty gave him, and he set it on the table because he had 3 times when he would not eat ice cream. It was before giving a speech, during a speech, and after a speech. So he wasn't going to eat it. Joe now, he finished his bowl of ice cream, and then he pointed to Fred's bowl and said, "Are you going to eat that?" Fred shook his head and said, "Be my guest." So Joe sat down at the table, and at each table was a jar of honey. This was one of Stan Anthony's special treats for customers that had helped make Pie 1 world famous. Some customers even liked to put honey on their pizzas. Ugh, that sounds awful. So, like I said, some customers liked to put honey on their pizza, poured half of the honey jar on his ice cream, and said, "This needs a little sweetening." Have you ever had honey on your ice cream? Doesn't sound good to me. So luckily, no one was listening to him, because watching Joe eat everything with honey on it, it could make a normal person sick to their stomach. Now, Darlene had only eaten 3 ounces of her bowl, and so she gave the rest to Joe. And this would be my equation if I was trying to figure out. I would have 1 quart, and Darlene had only eaten 3 ounces of it, and so I know I would have to subtract to see how much is left. So I can't take 3 ounces. Hang on. Okay, I can't take 3 ounces away from 1 quart. I've got to change this into ounces. So I'm going to mark that, and I know that 32 ounces equal a quart. Okay, so I can put my 32 ounces over here, and I can subtract the 3 from the 32, and I would have 29 ounces left. So you have done we've done lots of these measurement things where you have to sort of regroup, get the measurements, and put it over here. So there was 29 ounces left over after we figured out what was left over from the part that Darlene gave to Joe. Joe emptied the other half of the jar of honey on Darlene's bowl that had 29 ounces in it of ice cream. Joe got halfway through the 29 ounces that Darlene had given. So we need to find out how much did Joe eat if he got halfway through. So we would set up a division problem here. We would have the 29 here. We want halfway. Half of something is 2. So we're going to do 29 divided by 2. And 2 goes into 2 one time. Okay. We bring the 9 down. 2 goes into 9 4 times. That's going to be 8, and we'll have a remainder of 1. 2 cannot go into 1, so we would write it like that. 14 with the remainder of 1. Now, you can't really say that Joe ate 14 remainder 1 ounces. That makes no sense since we're talking about food. So we have to say it differently. And to say it differently, we do something like this. We take our remainder number, which is 1, and we take the divisor, which is 2, and we now would say that Joe ate 14 and a half ounces. Okay, does that make sense? I'll talk about it in just a second. So here's our rule. Just remember, this is a fraction line. The remainder goes on top, and the divisor goes here. So if I had, let's see, 3 into 10, and the answer is 3 remainder 1, my remainder would go on top, and my divisor is this one, and so I would have 3 1/3 ounces. Okay, so let's look at some more examples. Here we have, let's say, 14 divided by 3, and 14 divided by 3, 3 goes into 14 4 times, and then that's 12, and then we have a remainder of 2, and so we, instead of saying 4 and then an R and then 2, we do 4, we put the remainder here and the divisor right there. Okay, so this went there, that went there, and then we end up with 4 2/3. Someone can eat 4 2/3 ounces of ice cream. They can't eat 4 remainder 2. Let's look at a different one. Let's look over here. We have 7. Okay, so we have 39 divided by 7. We know that 7 goes into 39 5 times. That's right here. And we're going to have a remainder of 4. And so once again, we put the 4 right here. We take the 7 and put it right there. And our answer is 5 4/7. Okay? Now, this right here happens to be Joe's situation. He ate 14 and a half ounces. Now, Joe had eaten his own bowl, which was 1 quart, which was 32 ounces. He'd finished off Fred's bowl, which was another quart, and he ate half of Darlene's bowl, which is 14 and a half ounces. So now we take a little segue, I guess, and there's a little essay that Fred has. Before I do the essay, here was 1 quart equals 32 ounces, and again, what the amount that was eaten from Fred's bowl. Infinite versus finite is where we're at. This is a little essay that Fred throws in. And the question Fred is asking is, does Joe's stomach have infinite capacity? Okay, I'm back. Does Joe's stomach have infinite capacity? I don't know. If it was the gorilla's stomach, I think it would. So the essay that Fred writes is, nothing in the physical world is infinite. If you can touch it, taste it, smell it, hear it, or see it, it is physical and finite. Finite. Is everything finite? No. There's some things that are infinite, such as 1, 2, 3, 4, 5, even God. So if something is, these all go right here with finite. If it's goes on forever, if it can there's no end to it, that would be finite. And definitely this gorilla's stomach would be finite. If it's could go on forever. We could count numbers forever. God could go on forever. That is infinite. So those are two good words to remember. So no one had ever seen Joe stop eating. Joe could sit in front of his television and eat and eat and eat and eat. He would eat waffles, he would eat potato chips, he'd eat cake, he'd eat cookies, he'd eat candy bars. It didn't matter. Joe would eat it. Joe suddenly stopped eating. His eyeballs turned from blue from the ice being eating that cold ice cream. Then his face turned greenish orange, and he had overdone it. And he stood up and he walked quickly outside and he threw up everywhere. 5 minutes later, he came back in, but he didn't sit at the table where the 14.5 ounces of uneaten ice cream were waiting for him. I think he had enough. So, just to recap, he had 14.5 ounces from Darlene. He had 14.5 ounces from Joe, and that was 29. That equals 28 plus 1, because the 2 halves equal 1, which equals 29 ounces. And Joe was suddenly very, very quiet. It was now 20 minutes till 4, and Alexander had finished scooping out the quarts of ice cream for 200 people. There's 200 servings of ice cream here. And he goes back and he tries to put the ice cream machine kind of back together, but it was a mess. The machine was broken. The handle's broken, the top's off, gobs of ice cream all over the place. Everything needs to be washed and fixed, and so Alexander just gets a big gray sheet and covers up the machine so no one can see what it would look like, and no one needs any more ice cream. Okay, YTP, yay, 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 yay. Okay, number 1. Fred was looking at the booths. Remember, there was booths set up at Pi 1 on the north side of the restaurant. And this was, new to him what he saw. Fred knew that braces, these things right here, the braces, were things that were used to list elements. We could have shapes, we could have numbers, we could have flowers and cats and snakes. So the braces were used to list and to hold elements in them, because we've talked about sets and unions and all that. Fred is like looking at these braces and thinking, why would someone want braces made of brass? Seemed perplexing to him. The braces were being sold at the booth for 8 cents each. So Fred bought 8 of them and paid $1. 8 cents each. He bought 8 of them, and he's going to pay with $1. So we have to figure out what the fee will be. So to do that, you have to take 8 cents times the 8 braces that he got, figure out that answer, and then you have to count up from that answer to $1. You have to make change back. So if you had, so you have to count forward. So whatever this answer is right here, and let's just say, for example, that this answer was, let's say 70 cents. And I have to count back to $1 because Fred handed the booth person $1. I would count up. I would say 70, and then I would do, think I would use 5 cents, which is a nickel. I would get to 75, and then I would use a quarter, and that would get me to $1. So I would count back. I'd go 70, hand the person a nickel, and say 75. I'd hand them a quarter, and then I would say $1. That's how I would make change. So you have to figure out how to do what this multiplication problem is. Put the answer right there, and then figure out how do you count from that answer, how do you count back change to get to $1. We already did this, so it's exact same thing. Okay? Okay, for number 2, Darlene bought 9 braces at 8 cents each. So what you have to multiply 9 times 8, get an answer, and then whatever that answer is, you have to count back. You have to count the change to get to $1. Make sure that you're writing down how you would count back the change. Okay? Joe wanted to use these brass bases as weights for his fishing lines. So how many could he buy with $10? Don't know any fish that's going to eat them, but oh well. Or bite them so they could be caught. So let's think about how we set up our problem. And pay really close attention, because this is these kinds of problems are where some of y'all are making mistakes, little mistakes. So the question was, Joe wants to use these brass braces, and he wants to know how many he can buy with $10. So the first thing we have is $10. We also know that each brace is 8 cents. So we have those two numbers. I've written them. You should have written them down just like you would on any problem that's a word problem. Just write down the information and then figure out how we proceed. Would you multiply? Would you divide? So if you need to know how many of something, that's a division problem. So this is a division problem because you need to figure out how many can he buy. They're 8 cents a piece, so it would be 8 into $10. Okay? Then the next part of that same question would be, how many could he buy for $1,000 at 8 cents a piece? So you have two problems here to figure out. Number 4 is, how much would 100 braces cost? Okay? So we know this is a really good thing to do when you're doing word problems. Underline the numbers that you need to work with. How much would 100 braces cost? We know that each one costs 8 cents. So we know we have 100 and we have 8 cents. Now in this case, we're not dividing into something. We're not trying to figure out a part of something. We need to know we have 100 of them and they cost 8 cents a piece. So we would need to multiply that and see what they would cost. Now, because we're talking about 8 cents and 100, I want to show you something, and then you can come back to this. So let me show you an example, and then I'm going to come back to something. Okay. I'll see if I can explain this without confusing. So to multiply by 100, basically what you do is you add the zeros. So we have 6 cents times 100. I'm using 6 cents. Your problem has you using 8 cents. So 6 cents times 100, we write the 6 down, and then we add 2 zeros, because there's 2 zeros here, so we add the 2 zeros. We get 600 cents, but no one talks about 600 cents. That makes no sense. And so what I do then is I add a decimal point right there, and my answer is $6. Okay? So we're talking about cents here. We times it by 100, and all I had to do was write the 6 down and then add the 2 zeros. 6 plus equals, and what it equals is $6, because if I take these 2 zeros back off, I'm left with just $6. Now I want you to see how this works with the calculator, so you'll have to ask me for the calculator. But if we had, let's say again, using my example, 6 cents times 100, on a calculator I would put in 100. I'm doing it as I talk. I would hit the multiplication sign, and then I would type in 6 cents would be dot, the decimal point 0.06. That's 6 cents. So I'd enter that on the calculator, this on the calculator, and now I have to enter in so times 0.06 equals, and what shows up is just a 6, and we would know that that is going to be $6 because we don't want 600 cents. Okay? Does that make sense? So you can come up and use the calculator to see if that would help you. Okay, my dog is growling. I don't know why, but he's sitting here growling, so we'll ignore him. Can you hear him? Yep, he's growling. I'm going to try to see if he'll make the noise. Ah! See, now he's pawing at the thing. Sorry. Okay, the sheet that Alexander used to cover the broken machine was 9 feet long and 7 feet wide, and the question you have to answer is, what was the area of that sheet? Okay, don't panic. Okay, so just to help you remember, area equals L times W, which is written right there, which also means area equals L, and I put the time sign there, length times width, and then area equals, and then I replace, this is the L and this is the W, so I put the amounts that were given. So it said in the question that length was 9 feet, width was 7 feet, and then you have to solve what 9 times 7 equals right there, okay? And then remember that area is in, as a 2 there, it's in square feet, so you have to put the little 2 there. So you're solving what this is, and then add the feet squared to that. And that's it. That's all there is today. You didn't have to take very many notes, so you are done. Yes, you are.